Hello, everybody. We got another one. All right. Oh, these jokes are getting really bad. What do you give a sick lemon? Lemonade. Oh my goodness. All right. Let's get to it. Let's not waste any more time with those things I do for you guys. All right. By the way, this is 100th video. 100th video on YouTube. I reckon surely I don't know. I think I'm doing good. Okay. Application of the deriving logs. Again, any application of derivatives is basically going to be either A, curve sketching, or B, finding the equation of a tangent and a normal. Okay, so let's do this here. Make sure that we are comfortable with what we're doing. Find the equation of the tangent and the normal of y equals ln x at the point E1. So remember, tangent and normal, I'm thinking y minus y1 equals to m x minus x1. My point gradient, that means I need a point, which I do have. All I need now is a gradient, so I'm going to use my y dash. So y dash equals 1 on x, because that's just the derivative of an ln x or a log ex. Okay. And so at E1, my gradient of my tangent now becomes 1 over x, which in this case is 1 over e. And so while I'm here, my gradient of my normal is going to become the negative reciprocal. So it's going to be negative e. There you go. Kind of on the nicer side here. So that means if I use my tangent, gradient, and I'll keep my normal 1 over here. It's going to be y minus y1, which is 1, equals to m, which is 1 on e, bracket x minus x1, which is minus e. Let's clean this up as much as I can. What's the best way to do this? All right, I'm just going to expand it for this one. Any other time, I'll times the e over. You know what? Let's times the e over. Let's be consistent. Okay, I'll keep the e. Yeah, I should plan these before I do stuff. Hey, you know what I'm gonna do? I want to keep it as y equals because that's what I'm feeling today. So I'm going to multiply the e over. So, oh no, I'm not going to multiply the e over. I'm going to keep it as y equals. So it's just going to be y equals to 1 on ex minus 1, because 1 on e times negative e is just negative 1. And then also have that plus 1. So if you check that out, minus 1 and plus 1 cancel that. Whoop, and you're left with y equals 1 on ex. That there's the equation of your tangent. Boom. It's just got a gradient of 1 over e. All right, now if I want to find my normal, I do the same process. Y minus y1, which is negative, or which is 1, equals to m. And this time I just write negative e. X take away x1, which is e. And again, to make my life easy, I'm going to try keep it in my y equals form. So y equals to negative ex. This is not e to the x, it's just e times x. Plus, because it's minus times minus, plus e squared. And then I have plus 1. And there you go. Got a tangent, got a normal. Happy days. Okay. Now keep in mind here, e is a number. E actually represents an actual number. So that means this is actually a straight line. So both of these are straight lines. I know sometimes you see a squared and you're thinking, but isn't that a parabola? Not in this case, because e is just a nice number and we square it. It's not going to change. It's not a variable. Okay, the only variable here is x. Okay, now this one here, consider fx equals to x log ex. Couple things here. We're finding domain and range, talking about odd and even. We may have not have done it in a while. So let's find domain and range. Domain, if I look at the x values, are there certain x values that I can't be? Well, in a log, I know my x values have to be greater than 0. So in other words, x must be greater than, and I can't have 0. So x just has to be greater than 0. So writing that in your bracket form, what do they call that? The bracket form, it's just going to be between 0 and infinity. Now I can't equal 0, I can't equal infinity. That there's my domain. And range, now technically my range can be any value because x can equal any value. Log e of an x can be kind of any value. So basically here, my y is going to be between negative infinity and infinity. So in this case here, the way that you would write that would be from negative infinity to infinity. So that's all real y. Yep. Yep, that's right. Okay, odd, even, or neither. So the easiest way to check this is, remember, I'll write this here. Odd is if your f of negative x equals to negative fx. And then even is when you have f of negative x and it becomes just your regular fx. So let's try and see what happens here. If I go f of negative x, this becomes negative x times log e negative x. Now, is that the negative of, it's almost a negative, but in this case here, remember, the domain is kind of, it can't be even. It cannot be even. And in this case here, it doesn't look odd either, because it's not the negative version, because log e to the x is not the same as log e to the negative x. So in this case here, it's neither odd or even. Okay, so in this case here, we can kind of see, yep, neither. Okay, the part that makes it problematic is this part here. I've got to use different colors. I hope this is okay. All right, so that part there doesn't really work. Can't have log e of a negative number, doesn't work. So it's going to be undefined. Okay, define stationary points, determine nature and points of inflection, hence sketch. I'm going to put these two together so I can have a little bit of room here. All right, stationary points. First things first, let's derive this bad boy. How do you derive it? Let's use product rule. So if y equals to x, I'm going to write ln x just to shorten it. X ln x. So u will equal to x, v will equal to ln x, u dash will equal to 1, b dash is going to equal to 1 on x. So in this case here, my y dash now becomes ln x plus 1. That's kind of nice. How do I find a stationary point? Let y dash equal to 0. So we've got ln x equals to -1. And basically it's saying e to the power of -1 is supposed to equal to x. So in this case here, x equals to 1 on e. Okay. Now that there is just using my log law, and I'll write down what the log law is because it's log e x equals to -1. So what it really means, it's trying to say that this base to that power should equal that numeral. Okay, so that's why I wrote e to the -1 equals to x. And then I've just written e to the -1 as a positive indice. So that there is that. That's my stationary x value. Okay, so how do I find my y value? So y is going to equal to 1 on e times ln 1 on e. All right, so in other words, it's going to be 1 on e times log base e to the -1. All right, so in other words here, if I do that, the log e and the e cancel out, leaving me with 1 on e times -1, which is -1 on e. That there becomes my y. So my stationary point is going to be 1 on E, negative 1 on E. All right, there's my stationary point. Now to determine nature, let's do the second derivative. Okay, so we found out that y dash was ln x plus 1. Now let's look at our y double dash. Y double dash therefore equals just to 1 on x. That's clean. That's nice. Okay. And again, let's test at our point 1 on E, negative 1 on E. At this point, what happens to your y double dash? It becomes 1 on E. And look, I don't really need to know what that is. That just technically means E. And the way that this is, I just know E is greater than 0. So I know it's concave up. Therefore, I know it's a min stationary point. Okay. Now I've determined its nature. Are there any points of inflection? All right, points of inflection. Let y double dash equal 0. So I'm going to let 0 equals to 1 on x. And so there's no point of inflection here. Right, because I can't times the x over, it'll disappear. Can't take the reciprocal, won't work because I can't have anything over 0. So that just is what it is. Undefined slash none. Okay. So now that we've got that, we've found the stationary point or points, we've determined nature, and we've found the point of, there's no point of inflection. So now let's see if we can sketch it. Okay, so if we were to sketch this, what are we kind of looking for? There's a couple things. The main one, the main thing it'll look at is we've got, I guess, the equivalent of 1 on E, negative 1 on E, whatever that is. And I know that there's probably going to be y equals to x log ex. The easiest way is let's find the y-intercept by letting x equal 0. When x equals to 0, it's just going to be 0. All right, so when x equals 0, y has to equal 0 in this case, because if I substitute it in, that's going to turn everything to 0. So I know I'm going to kind of come down. I know that that's a minimum. And so it's got to look something like this. All right, because I know we've got a minimum point. There's no point of inflection, so that means it's going to be concave up the whole way. That's it. Happy to leave my graph looking a little bit more like that. And that's it. Hopefully that helps. I'll catch you guys later, and bye-bye.